and welcome to another video. In this video we're going to be going through chapter 1.3, Conservation of Momentum. Now to start off, we need to imagine we have two balls before and two balls after. Now imagine this ball collides with this ball, and after they both will move with a velocity. Now let's put this into a formula. The mass of A, we'll call this A, call this B, call this A, call this B. The mass of A multiplied by the velocity, which will label U of A, plus the mass of B times the U of B will be equal to the mass of A, we'll call it little a, and the V, we'll use a V this time, this A, plus the mass of B times the velocity of B. Now, this number here can be used in the formula F equals the momentum of this changes to be the momentum of this. So we can go M A U A minus this one here, M A V A over time. That will be our change. So if we look at the next page, if these two objects collide and they get stuck together, like so, M A U A plus M B U B will equal the combined mass. So M A plus M B, all in brackets, times, because they'll be connected, they will share V. So all multiplied by V. Now this is what you want to use when two things become stuck together, and this is what you want to use in the other cases. Now, with these two formulas in mind, let's move on to a couple of questions. So, question 1. A rail wagon of mass 3,000 kilograms, moving at a velocity of 1.2 meters per second, collides with a stationary wagon of 2,000 kilograms. So 2,000 kilograms, 0 meters per second. Now what I like to do to tackle these questions is to draw a nice little diagram. So we want to have this wagon here, doesn't have to be fancy, colliding with this wagon here. Now it says that the two wagons couple together, so after the collision they will become one mass. Now to make this even better, we'll label the mass here and the mass of this one and the velocity of this one, and we know that the velocity of this one is 0, and we know that the combined mass will be 5,000 kilograms, and we're trying to find V here. Right, so we can use our formula. We know the mass of A, we know the mass of B, so we do 3,000 multiplied by 1.2 plus the momentum of this one, which will be 0, because 2,000 times 0 is 0, and this will go to 5,000 multiplied by our V that we're looking for. Now this simplifies down to being 3,600 equals 5,000 V. Now to get V on its own, we divide by 5,000. So 3,600 divided by 5,000 will be equal to V. Now that will give us 0.72. So V, the velocity after the collision, will be 0.72 meters per second. So that's question 1. Question 2. A rail wagon of mass 5,000 kilograms, let's draw a diagram again, 5,000 kilograms, moving at a velocity of 1.6 meters per second, collides with a stationary wagon of mass 3,000. So collides with a stationary wagon of 3,000. After the collision, the stationary wagon, which we're going to call B, the stationary wagon is here, A is here. They both move away now. This is still 5,000, this is still 3,000, and it tells us that the velocity of this one, the stationary wagon, is 1.5 meters per second. What we need to find is this. So again, this is equal to 0, 1.6 times 5,000 plus 0 going to 5,000 V plus 3,000 times 1.5. Now, we want to find the speed and direction of the 5,000 kilogram wagon. I'll get rid of this arrow for now, just in case it isn't going that direction. So, first we take this, which is equal to 8,000, plus 0 is equal to 4,500 plus 5,000 V. Right. Now, again, we need to get V on its own. So we take away 4,500 from both sides. So we get 3,500 here is equal to 5,000 V. Yeah. So now we divide by 5,000 again. So, which gives us V. Now V this time is going to be .7 meters per second. Now, in terms of the direction, we can say that because the number's positive, that the direction will be the same that it was initially moving. So we can say that the direction is to the right. Let's move on to question 3. Now, this says, in a laboratory experiment, a trolley of mass 0.5 kilograms, moving at a speed of 0.25 meters per second, collided with a trolley of 1 kilogram. 1 kilogram. In an opposite direction. So they were colliding like this at a speed of 0.2. Right, okay. And this will then, the trolleys couple together. So we've got this again. So the combined mass is 1.5, and it wants us to find their velocity straight after the collision. Now in this case, because they're both coming together, we work out the momentum of this one and we take it away from the momentum of this one. So in this case we have 0.25 times 0.5, which gives us 0.125, and this one is going to be 0.2 multiplied by 1, which is obviously just 0.2. So we have 0.125 minus 0.2. Now this gives us a negative number, but this isn't the end of the world. If we do this, we end up with minus 0.075. This number is then equal to 1.5v. So if we divide this by 1.5, we will get v. This gives us that v is equal to minus 0.05 meters per second. Now what the minus tells us is that the trolley will be moving this way after the collision. And that is that question. Right, last question. Question 4. Right. So this says a ball of mass 0.8 kilograms moving at a speed of 2.5 meters per second along a straight line collided with a ball of mass 2.5 kilograms, which was initially stationary. Now after this collision, we are told that the 2.5 kilogram ball is moving at a velocity of 1 meter per second. Calculate the speed and direction of this ball. So we're looking for this one now. So again, we just take the initial momentum this side, plus 0, because our velocity is 0. We'll go to 0.8v plus, and we know this because it does not say that they are a couple. So 2.5, because it's 2.5 times 1. We take this away from this once we've worked that out. So we have 2 minus 2.5 gives us 0.8v. Now, this is going to be minus 0.5 equals 0.8v. So minus 0.5 divided by 0.8 give us v. Now v in this case will be equal to minus 0.625 meters per second minus 1. And again, the minus sign tells us this will be moving like this. So it's hit that first ball, it's hit the ball and rebounded with this speed. That was chapter 1.3. Hope it's been helpful. Please like, subscribe. Thank you for watching.